Watch this. Ah! I need no clip for this. Hello, beautiful. You look very geat today. Because you will learn how to make your very first Noclip hack. A Noclip works in the way that the player can sort of fly through the walls in any direction, which is normally a console command feature in many games. But we don't need that, because console commands are for nerds, and we will do all of the Noclip logic ourselves. This tutorial is meant to work for almost all games out there. You just have to tweak some minor things. Although this might be applicable to your game, you will still have to research the terms of agreement / usage for the underlying game, since memory reading / writing might not be allowed. I love making this tutorial for you guys, but in order for me to be able to keep this up, I will need your guys' support. So please subscribe, leave a like and a pleasant comment. I might even respond to it. The Discord link is now fixed, so please join the fun. And with that out of the way, please enjoy this tutorial. Welcome to today's showcase. Here I have the game Assault Cube, and we are going to create the infamous, the unimaginable Noclip. So let me open the final project. Here you go. It's not a whole lot. It's like 100 lines or something. And if we run it, we can see our beautiful little menu here. And it says disabled or enabled if we hold the desired hotkey. So in game, if we hold the hotkey, if we jump, hold the hotkey, we are floating in midair. So that means the Noclip is enabled. We can also just hold the W key to move around through walls, through the floor, through the roof, through the roof, wherever you want. You can also use A and D keys to fly around wherever you want. So this is an incredibly fun project to do and not that complicated. You will surely be or have a great time following this tutorial. So I hope you guys enjoy and have fun. Welcome to today's tutorial. We will start by finding the necessary addresses and offsets to make our Noclip work. So here I have a notepad of the final notes that we will have after this first part, and that will be notes of the player address. So we will find the player's address and the offset that leads to the position of that character, XYZ. We will also find the view angles of our character, which will be the yaw and pitch. Then we will find the instruction that moves the character or makes the character fall. So we can we need this because we want to disable it so our character doesn't fall and we can Noclip without falling. So let's remove that and get right into our game. Alright, so I have the game open. Mine is Assault Cube, the perfect game to do this on. And we have Sheet Engine, our trusty tool. So, because the character in Assault Cube has the view angles, or the view has, he looks a certain way, so he has view angles, and he has the position. That means we can find one attribute of the character, like the health, or the ammo. Well, let's choose health, and then find these other offsets a little bit easier. So let's find our health value first by searching for 100, finding a grenade. And there we go. Taking the grenade, throwing it against the corner, taking some damage. Now we have 64. If we search for 64, we have 2 addresses left. Let's pick the first one, set it to 111. We can see that this is our health offset or health value. Now, because we have the health value, we can easily find the other attributes just by pointer scanning. So pointer scan for this address. I will choose the max level to 1 because I know it will only be 1 offset for my game. So you can choose more for your and so on. And the help when we search for our pointer scan, we will have some results. So I will pick this first main module pointer. It's the main module because it says .exe here, and it has the offset f8. We can call this player. We can now remove the offset and Control B, Control D, Control N to open a new structure. Here we can see pointer to instance of player ent or entity. So this means we have found the player object, the player address, and then we can scroll down, click on this arrow and scroll down to see our different attributes. So the help was at f8. F8 is down here under the level like that, but we are looking for some coordinates. So let's go in game with the window open and jump. So we can see at C it's a 4.5. Let's change it and see what happens. Let's change it to 9. Nothing happened, only the camera shaked. So probably not that one. Let's jump again. And here you can see 2 addresses. If we move around, you can see that they change. So let's try and change this last offset of these 2 to a float. Still 0. And change it to 4. You can see that our character flew. So here is the X, Y, C or Z values probably. Here we can change this 125 and we teleported. So this is definitely our X, Y, and Z values. So we have these down. Let's brighten down now. So we have the player, have that base address like that. Then we have the offset 34 equals position. Or we can write it like this. Player address x34 equals position. Now we need the view angles. So view angles will be somewhere here as well. Let's move the crosshair and look for them. Right below the X, Y, and Z, we can see 2 addresses that, whoa, I threw a grenade, that go positive 90 when we look up and minus 90 when we look down. So that's looks like some view angles that we would want. So if we change these, let's change it to 50, the pitch he moved up. So this is definitely our view angles. You can see that it goes from 0 to 360 then resets. So our view angles right here at offset 40, we can write that down as well. Let's just copy that and write 40 equals view angles. There we go. So we have found the view angle or the position and view angles from our player object. Let's add the Z axis, or it doesn't matter the axis. Let's add the position to our address in the address table. So we close these ones down and we remove that. Change this to X axis or maybe Z axis. And we add as a pointer the offset 34. Now it should be X axis, but whatever. If we change this to float, we can see the X axis. We will take this Z axis and we will find out what writes to this address. So you can enable VEH in the debugger. It will crash less if you do that. So enable VEH debugger. Then right click, find out what writes to this address. And this will, yeah. Once that's done, you can click on stop. And so this is the x-axis, but yeah, it's moving the character somehow. So it's handling our character's momentum. If we go into the disassembler, we can see a lot of complicated stuff. But what we're looking for is some sort of comparison or test within these opcodes that test certain values. It would be like an if statement that we can disable to disable the following mechanism. So here we have test BL and BL. If we test the test and make it replace with code that does nothing, nothing happens. We move on to the next one. Move test. Here we have BL and BL. We test that one. Replace with code that does nothing. Something happens. Let's restore that. So that wasn't the one, as you could see. Then we have test EAX with EAX. Replace with code that does nothing. We just have less gravity, but it's not the one we're looking for. So restore with original code. Here we have a test, but that's inside of a loop, so you don't want to change that. At least not for now. Maybe if you have done more analysis. But here we have a last test. Let's replace that with code that does nothing. And now our character doesn't move. So if we restore with original code, he can move again. So we will just do in the program like this, replace with code that does nothing, and our character will be flying or will be static in the air while we can noclip. So restore with original bytes, then we go into the notepad again and write down this address. So we copy to clipboard, addresses only, and we write move character instruction. And here we have the original bytes, which are the 85 and C0. If you have multiple bytes, you can just right click, copy to clipboard, bytes only, no address. No. There we go. Original bytes. And we have the new bytes, which are the ones when we make them useless or code that does nothing. No. Here we have 9090. That's the new bytes. 9090. So here we have all of the needed offsets and stuff to make our noclip. Now let's try and make this. So the first thing we will do is create a new console project with the name of Noclip or something. It will have the version 6 of the .NET framework. The first thing we will do is to remove the template code, then install the swedz32 or swedz64 NuGet package, depending on your underlying process. Then we will go into properties of the project and set our build to 86 if you have 32-bit or 64 if you have 64-bit. Then the first thing we will write is using swedz32 and using system.numerics. This will be for handling vectors and the memory. Then we will create an instance of the swed class and use the process name. So you can get the process name from JIT-Engine if you don't know it. AssaultCube, it will be AC_client. Next up will be to define some addresses so that we can read from the game's memory efficiently. The first address will be the module base, which we get from the swed.getModuleBase. Then we have the player position, which we get from the module base and the offset of the player, plus the last offset 34. Next up will be the view angles address. we will use, like before, the module base and the player offset. Now this is the same, but just to show, we will use the same lineup, but now use +40 at the end to get to the view angles instead of the position. Now, the last address will be the move instruction address, which is the falling mechanism, if you remember, the thing that makes us fall. So we will take the module base and directly add the address. We will not use the read pointer because we're not supposed to read a pointer here. Now let's declare some variables. The first two vectors, current position and view angles, will of course hold our current position and then our view angles. Then the move speed will be the distance that will move in a direction with our noclip. We will set it to 0.3. Degree to radian will be a simple mathematical division to convert degrees to radians. We do that by dividing pi by 180. Then we have angles offset. This is for a solid cube only, kind of, because we will have to offset the view angles by 90 degrees in our case for it to work properly, or for the calculation to be correct. For the view angles to align with the x-axis. And like I mentioned before, this will be different for different games, so you will have to find out these angles and positions and so on that works for your game. You cannot just rely on this. Different games might use radians, then you don't have to convert. Games might use a different way for the falling mechanism. You will have to find out these on your own. This is just a template and it will work for a solid cube. Next up will be to create a while loop that is always running. Then a noclip method that will teleport our player at the correct coordinates. Then we will have some imports, or one particular import, which is the getAsync key state. It will get the state of a button on your keyboard, and we can use this to handle our user input. Now that we have the getAsync key state available, we can check if we're holding our W key down. And of course, we will add more keys later. But before we can move the character, we will need the current data for our player so we can calculate the new position. We get the current data by setting the view angles, x and y, to the swedz.read float and then view angles address. We add 4 in hex to offset to the next float, because a float is 4 bytes. Then we will get the current position by reading the vector of our player position. Then we will just create some new variables with the current position values to perform calculations. Now, with the noclip, we will have to think about the forward movement, the backwards movement, and the left and right movements. So we're going to start with the forward x to calculate the new position on the x-axis by taking the move speed, the cosine of the view angles.x, our yaw, with the degree to radian conversion minus the angle offset. This is because, as you can see on the picture here below, we replace the adjacent with our x, the opposite with our y, and our view angles.x is our yaw, or the angle here, which means if we want to solve for the adjacent, we can take the cosine angle times the hypotenuse, or our move speed. So we just substitute with our values instead. Now, next in line will be the y-axis. So let's calculate the forward y, not t, I made a spelling error here. We will calculate this forward y by taking the opposite and the hypotenuse and the sinus angle. So just like before, we will substitute with the hypotenuse, and instead of the adjacent, we use the opposite and use the sinus angle. Next in line will be the forward z for the z-axis. we'll calculate it by taking the move speed or the hypotenuse, then the math.sinus with now the view angles.y and just convert it to radians. We do not need to align the angles with the x-axis or something similar because our pitch was fine in our case. So that's how we calculate the forward z. It's just like before with the forward y, how we substitute for the sinus. Now these calculations might have already been a lot for some people, so we will go directly on moving the character now. So for the W key or going forward, we will just plus and equal the forward x, y, and z to our new x, y, z, which will move the character in front of us. Now, because we want to add more moves later, we will sum all of the moves in the end by taking a new position, which will equal to a new vector that has the new x, y, z in it. Then we will use the swedz vector and use the position address and our new position. This will teleport the player to the final position. Now, nothing is calling our Noclip method yet, so we will go into our main loop and create a while loop for the getAsync key state. So, whilst we hold a hotkey, we will want to enable the Noclip. So, I will use the mouse 504 or the 0x6 for my hotkey. You can choose whatever hotkey you want. And if our hotkey is down, we will disable the following mechanism by using swedz.writeBytes, then the move instruction address, with some bytes that do nothing, 9090 or nops do nothing. So we will remove the following mechanism, then call our Noclip method to move us in a direction. Then at the end, after when we have released our hotkey, we will write back the original bytes. And we should Noclip when we hold W. So here we have the game, here we have the app. Let's start it, run it. My computer is a bit slow, but then when we run it, it shouldn't close. And when we go in game, if we jump and hold the hotkey, we should be floating in air because we have removed the falling mechanism. So if we hold the key now and hold W, we will Noclip. Would you look at that? We don't have a method yet for going backwards and sideways. We will add that. Don't worry about it. But as you can see here, we're Noclipping. So this is already pretty insane by itself. Now, the next step will be to add some color indicators to show us when we're Noclipping and when we're not Noclipping. So we will clear the console, then change the foreground to red because we're not holding our hotkey at this point. Then we will write the text Noclip disabled. So that's for outside of the loop when we're not Noclipping. We can take this code and copy, paste it inside of our getAsync key state loop and just replace the color with green and the text with enabled to let us know that we're Noclipping. Okay, good. We have color indicators now. Let's add the next keys that we will use. So it will be the WASD, so ASD, the new ones. And I also wanted to add a jump key and a control key to take us up or down more easily. Now, because we want to use the A and D key, we will have to add some new calculations, which will be the right X and the right Y. This will, instead of moving us in front or back, we will calculate the new positions for our left and right. So, like before, we will do our substitution within the sinus and cosinus multiplications to get the new axis coordinates. Now that we have the new calculations, we can just add the rest of the keys. So the S key will just be the forward key or the W key, but inverted. So instead of plus equals forward XYZ, we will have minus equals forward XYZ. Then for the A and D key, we will just take the new X plus equals right X, the new Y minus equals right Y, and vice versa for the D key. So I might have messed up here with the naming and so on. You guys can fix me in the comments. Then for the jump key and the control key, we will just do plus equals on the new Z axis, or minus if you hold control. Alright, let's try out our results. If we press start, we have our application here. If we hold the hotkey, then Noclip is enabled and it's green. If not, it's disabled and red. But let's check it in game as well. So here we have the window, here we have the game. If we hold W, we can Noclip like before, forward. If we hold S, we go backwards. If we hold left, we go to the left. If we go right, we go to the right. And there you go. So a Noclip, you can fly wherever you want. It doesn't matter where. Here we are on top of the map. Top of that thing. You can fly wherever you want. Anywhere. Doesn't matter. With some style. And I hope you guys enjoyed this tutorial and learned something. I will see you guys in the next tutorial. Have a good one.